Welcome back. In the previous video, we discussed what software quality is, and through some figures, we saw how it can affect adversely in different situations. In this video, we will discuss some more definitions of uh, important concepts such as quality assurance and quality engineering. Understand the concepts of software quality assurance and quality engineering. First of all, it is important to distinguish between the quality control and quality assurance. What is quality control? It is an activity, it is in fact a set of activities to ensure quality in the completed or finished products. These activities mainly emphasize on identifying defects in the actual products that are produced. An example of such type of activities for now might be considered as the testing activity. So what is the objective of testing activity? That when we perform testing of a developed software system, what is our focus? Our focus is on identification of defects, that if there are any problems, there are any defects in the system, those are to be identified in that activity. So testing can be considered as a part of software quality control. So therefore we call quality control as a reactive process. Why we are calling it as a reactive process? Because the product is now complete and we want to identify the defects in that product. What is quality assurance? Now, quality assurance is a set of activities for ensuring quality in the development process. Now, just compare this definition with that of quality control. That quality control is only focused on identification of defect, whereas here we are concerned with applying quality assurance procedures on all the development activities of a software system. So there are several types of activities that are performed at different stages of the life cycle of software development. For example, there are certain quality assurance activities that are applied in requirements analysis stage. Similarly, there are activities that are applied at design stage and later stages. Therefore, the aim of the quality assurance activities is to prevent the defects. And it is that's why it is called as a proactive quality process, that we are in fact proactive here in preventing the defects from originating. So mainly what is the difference between the two? That the goal of the quality control is to identify defects after a product is developed and before it is released, whereas the goal of quality assurance is to improve development and test processes so that defects do not arise when the product is being developed. Here we see another distinction between the testing, quality assurance, and software quality engineering. In fact, all these activities, they are of course interrelated to each other. For example, in the previous slide we had discussed that testing can be considered as an integral part of quality control, and in fact it is like hard to separate quality control from quality assurance. In fact, quality assurance, as we had discussed, that it is applying quality assurance procedures on the overall process. So in the overall development process, quality control can also be is also considered. For example, quality control is also applied, testing is also applied. So what testing actually is, that by running the software systems or executing its prescribed functions, The testers can determine if the observed system behavior conforms to its specifications or the requirements. Whereas, here, that can be seen that in this figure we have a small rectangle for testing. It shows that testing is in fact not the whole of these activities. It is just one portion or one small fragment of the overall set of activities. Whereas quality assurance that in fact covers a broader portion, and it has in fact more activities. So in fact testing can be considered as a part of quality assurance activities, but it has some additional activities. For example, it may contain inspection activities. For example, we may inspect any artifact. Similarly, it may consider applying formal verification techniques. Similarly, defect prevention techniques and fault tolerance techniques, fault containment techniques. They all are a part of quality assurance. Now, software quality engineering. So, if you see this illustration, so software quality engineering is in fact that is in fact encompassing software quality assurance and testing. So it means that software quality engineering, it is in fact the management and application of software quality assurance procedures, where we have quality engineering processes with quality goals set early in the product development, and the strategies for quality assurance, they are selected and they are applied, and of course their monitoring is important. So mainly software quality engineering is a broader activity that overall emphasizes on the management of this set of quality assurance activities. Now, once we know the difference between the quality assurance and quality engineering, it is important to understand why software quality engineering is important. For that, we have to answer some questions. For example, we need to ask, like, first of all, why software? Then why quality is important? And then why engineering? So, why software? Because in contemporary social life, software systems and services provided by software, they are omnipresent, means they are present everywhere, and software is in fact being deployed in like all domains of human life. For example, beginning with watches, like we wear in our hands. Similarly, they are being used in nuclear control, electricity plants, and spaceships. And so we see that the software is everywhere. That's why quality is important, because if the software is being used in these like safety critical systems or domains, of course we want to uh, work on the quality of the system, so that we may avoid any adverse situations. Because if these instances of software, like we've seen, for example, they work without the desired quality, then what are the consequences? We may be late, we may be dead, or lost in space. Then why engineering? Because in every technical domain, it is engineering that transforms ideas into products. It is, in fact, the verified and validated set of to-dos that help develop the product that not only has required functionalities, but also executes them correctly. That's why software quality engineering is important, not only to perform the desired functions of the systems correctly, but also to manage those functions and performing the activities related to those functions in a managed and a systematic way. Okay, here we will discuss the importance of quality assurance and quality engineering activities with respect to the activities performed at different stages of the development life cycle. For example, requirement specification, design, construction, deployment, etc. So first we see what quality has to do with the requirements. Performing quality assurance in requirements engineering phase has a great impact on the product quality. It checks whether the requirements possess the desired attributes, that is they're consistent, complete, and correct. Therefore, quality assurance of the requirements is important because the cost of requirements failure is very high. Then software design. Of course, design has a prevalent impact on the product quality. So design decisions can impact various software quality attributes. And lack of quality in the design process can not only invalidate good requirements, specifications, but also can make the correct implementation impossible. Then the construction phase. By construction, we mean that it is the activity of writing the code in any programming language. So the construction also has an obvious relationship with quality because the correct implementation of the user requirements and the subsequent design models is necessary to ensure the quality of the product. Then deployment. Deployment is in fact deployment of the software onto physical hosts or the target systems. So deployment is a very important concern that affects the system's quality. For example, the decision to deploy high quality software on low capacity hardware will result in degraded performance of the system and will eventually lead to the quality issues. So we see that quality assurance activities are strongly linked to different phases of software lifecycle, and performing these activities ensures the quality in the resulting products. So that's all about our discussion on the quality assurance, quality engineering, and importance of quality assurance activities with respect to the software lifecycle activities. In the next video of this lecture, I will discuss the quality views and quality expectations. Please watch that video. Thank you.